right, everybody, let's wrap up our discussion of independent samples t-test in the context of hypothesis testing. So remember, here we have our general question: are psychology majors more intelligent than philosophy majors? We specify that more technically with the research question: do psych majors have a significantly higher average IQ than philosophy majors' average IQ? So we have the same 7 steps for the t-test. In fact, the steps are the same in every single t-test. The only thing that would be different is how we would calculate our t-score, but everything else is identical here. So we have our variables. Remember, we have a categorical independent variable, which is majors. Psych and philosophy are our 2 groups measuring our major here. We have our 2 majors that we're studying. And we have a dependent variable, IQ scores. It's a continuous variable ranging from 70 to 180. We want to know, is there a difference in IQ scores based on the major that you are in? So we have our hypotheses that we went over last time. So we have the directional version. If the question is directional, turns out that our question is, if it's non-directional, our question is directional. So our hypotheses will be directional. And psychology majors have a significantly higher IQ. So our alternative is going to say higher, and the null will say lower or equal to, just like you see here. So let's put this together, okay? So we have our question, we have our variables, we have our data there, we have our hypotheses. So remember, it's directional, so the alternative says that sample 1 will be greater than sample 2. The null says that sample 1 will be less than or equal to sample 2. And then we calculate our t-score. We did this last time. So we have a t-score of 3.330, representing the difference between our average IQs of our groups with sampling error. Sampling error is quite large, so maybe this t-score is smaller than it would be because of how much sampling error we have. That's a possibility. So what we need to determine is how likely were we to find this difference between psych and philosophy majors' average IQs? Was it likely or unlikely that we would find this sample that gave us this difference between their average IQs? So we need to find the probability of this t-score, and if it's less than 0.05, then finding it was unlikely. So let's look at how we can compare our calculated score to our critical score. Now, you find your critical score in the same way that you found it with the 1 sample t-test. It's going to have the same process. You have your alpha level, you have your versus 2 versus 1 tail test. Now remember that when it's a 2-tailed test, the crit goes on both tails. When it's a 1-tailed test, the crit goes on only 1 tail, and you determine which tail based on the alternative hypothesis. Now, in independent samples t-test, the degrees of freedom is calculated using the sample mean of sample group 1, of sample 1, plus the sample size of sample 1, the sample size of sample 2, add them together, and then subtract 2 from them. And that's how you find your degrees of freedom. Now, don't forget that the software you're going to use calculates degrees of freedom for you for all the stats, pretty much. So you need to know how it is conceptually, because you might be asked questions about it like on the quiz, but when you're doing the problem assignments, degrees of freedom are calculated for you. All right, so you just take the number that the software gives you and then just use that to move forward. So, but we're doing it by hand, so let's see how we can find it. So alpha is 0.05, we've got a 1-tailed test. We have our 2 sample sizes there, okay? Now remember, if DF is not on the table, you round down to the next lowest listed, and you need to determine, is the t-crit going to be a positive or a negative number, depending on which tail it should go on, okay? So pause the video, try to locate the crit score, and then let's move forward. So the crit that you should have found is positive 1.813. Now it's a positive crit because our alternative says greater than. So because it says greater than, the crit goes on the positive tail. Now we need to compare our t-score to it. So 3.330 does in fact go past positive 1.813. So because it goes past, we know that it has a probability less than 0.05. It was unlikely to find this difference, assuming there isn't a difference between the major's IQ. So that's evidence against the null. We're going to reject it and accept our alternative as our conclusion. So you just copy and paste the alternative hypothesis for your research conclusion. Psychology majors' average IQ is significantly higher than philosophy majors' average IQ. And then lastly, you need to then put it together in the general conclusion, put it back in the language of the general question. And it could sound like this. Psychology majors are more intelligent than philosophy majors, okay? Now, one thing that I want to bring to your attention here is that with certain stats, we can use visuals to represent our data. Remember, like we use histograms to represent frequency distributions? Well, with the independent samples t-test, when we have two group means, we can use a bar graph to represent how different our means are from each other. Now you can see that based on the bar graphs, the difference in the heights can indicate how large the difference is. And usually the larger the difference, the more likely the result may be significant. Not always, but it could be more likely the case. So we can see just by looking at the bar graph here, psychology IQ is much higher than philosophy IQ based on this data. So that might visually indicate to us that this difference might be statistically significant. So when you do the problem set for the independent samples t-test, you'll have a question on there that's asking you to calculate or to create a graph to visually show the difference between your means. And that can give you a little indication of where your analysis might be heading. Is it going to be significantly different or not? Okay, and that is how you do the independent samples t-test in the context of hypothesis testing.